बिस्मिल्लाहिर्रहमानिर्रहीम मैथमेटिक्स सोल्यूशन बाय ज़ीशान तौक़ीर में सबको अस्सलामु अलैकुम। 11th chapter mathematical induction. First we mathematical induction. It is the method by which we prove that a given formula is true. It is a method by which we prove that a given formula is true. Here we satisfy two conditions. What is the condition? First, given formula is true for starting value n is equal to 1. The given formula is true for the starting value n is equal to 1. And the condition 2, we assume that formula to be true for n is equal to k. What is k? K is the positive integer. Prove that formula is true for n is equal to k plus 1, and then induction is completed. Condition 1, given formula is true for the starting value, say n is equal to 1. Condition 2, we assume that formula is true for n is equal to k, positive integer. Prove that formula is true for n is equal to k plus 1. Induction is completed. Now we start question number 1. Exercise 8.1. Question number 1. We have to solve it by using first condition. We have to solve it by using first condition. First condition, for n is equal to 1, we have to put n in this term and this term, and we have to prove that left hand side equal right hand side. Now put n is equal to 1. 4 is to 1 minus 3, and then right hand side 1. 2 is to 1 minus 3. Sorry, this is 1. 2n minus 1. What happened? 4 minus 3, 1 is equal to 1. It means condition 1 is satisfied. Condition 1 is satisfied. Condition 1, how condition 1 is satisfied? When we put n1, left hand side is equal to right hand side. Now suppose that above statement is true. Suppose that above statement is true. Suppose that above statement is true for n is equal to k. Now put in this n is equal to k. 1 plus 5 plus 4 k minus 3 equal k is to 2k minus 1. This is equation number 1. Now we have to prove it is true for n is equal to k plus 1. Now put in this n is equal to k plus 1. It means it becomes plus. Now we have to put for n is equal to k plus 1. It becomes 1 plus 5 plus 9. Put n is equal to k plus 1. Every value of n we have to put k is equal to 1, plus up to so on 4k minus 3, and in the next term in this value put k is equal to k plus 1. 4 is to k plus 1 minus 3 equal, in this right hand side put k is equal to k plus 1. 2 is to k plus 1 minus 1, and then the term become 1 plus 5 plus 9 up to so on 4k minus 3. When we solve this term, 4k plus 4 1 the 4 minus 3 1, 4k plus 1 equal k plus 1. 2k plus 2 1 the 2 minus 1 1, then 2k plus 1. This is equation number 2. Now we add this term on equation number 1 on both sides, on left hand and on right hand. We add, keep in mind, now we add both term 4k plus 1, this term 4k plus 1 on question number 1 on left and right hand side. It becomes 1 plus 5 plus 9 up to so on 4k minus 3 plus 4k plus 1 equal k is to 2k minus 1. K is to 2k minus 1 plus 4k plus 1, and the result is 1 plus 5 plus 9 up to so on 4k minus 3 plus 4k plus 1. When we multiply, k k becomes 2k square minus k plus 4k plus 1. It becomes 2k square plus 3k plus 1. We have to factorize. When we break the midterm, when we multiply it becomes 2, and when we add 3 it means 2k plus 1k. When we take common 2k it becomes k plus 1. When we take common plus 1 it becomes k plus 1. K plus 1, k plus 1 take common, the result is 2k plus 1. This becomes equation number 3. This equation becomes equation number 3. Hence equation number. Now what is equation number 2 and what is equation number 3? Now we prove equation number 2 and equation number 3 are equal. So condition 2 is satisfied. It is true for n is equal to k plus 1. Condition 2 is satisfied. It is true for n is equal to k plus 1. Hence it is true for all positive integers n. Hence it is true for all positive integers n. बहुत शुक्रिया, जज़ाकल्लाह, खुश रहें हमेशा.